Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over some Unit 4 concepts on magnetism. A basic law of magnetic attraction: like poles repel, unlike poles attract. So if I have a permanent bar magnet, orientation north and south as we see here for bar magnet number 1, orientation for bar magnet number 2, south to north pole. Two like poles repel, that becomes a force of repulsion. If I now flip these magnets around, orientation of bar magnet number 1, north pole is here. Orientation of bar magnet number 2, south pole is here. Unlike poles attract, that now becomes a force of attraction. In any permanent magnet, whether it's a bar magnet or the horseshoe magnet I have represented here, notice the north and south poles. Magnetic lines of flux always travel from the north to the south pole. Another interesting feature about a permanent magnet: pretend my dry erase marker is a reasonable facsimile for a bar magnet, has a north and a south pole. In nature, a permanent magnet cannot exist as what's called a monopole, meaning it only has one pole, either a north or a south pole. A permanent magnet must exist in nature as what's called a dipole, meaning it has both a north and a south pole. So if I were to take this permanent bar magnet, slice it in half with a bandsaw, and produce two brand new bar magnets, the magnetic domains would reorient themselves in the magnetic material, so each would have a corresponding north and south pole. Another principle we will be interested in is electromagnetism, the idea of how does electricity and magnetism interact with each other. Well, two primary laws that we're going to be concerned with in our study in Unit 4, the concept of whenever I pass current through a conductor, it doesn't matter if it's AC or DC electrical system, whenever I pass current through a conductor, I basically generate magnetism or magnetic flux about the conductor. The second principle: when I have a conductor in motion in a magnetic field, I induce a voltage in that conductor that is in motion and set up current flow. So induced voltage sets up current flow in the conductor. Another item to keep in mind, the term ferromagnetic, and you will see definitions of ferromagnetic, paramagnetic, and diamagnetic within Unit 4, but primarily ferromagnetic. Ferrous, from the Latin Fe, ferrous for iron, meaning that I could have a metal, but if I don't have an iron component, the metal is not going to be magnetic. For example, copper is a conductor, copper is a metal, but it doesn't have an iron component, so copper is non-ferromagnetic. Likewise, aluminum. Aluminum is a conductor, aluminum is a metal, but there is no iron component within aluminum, so aluminum is also non-ferromagnetic, meaning both copper and aluminum, neither of those act or have magnetic properties. All right, so please read information in Unit 4. I have a video and magnetism as well for you to take a look at, and there's a corresponding PowerPoint on magnets. All right, have a great week. See you next week.